Alright, so I'm going to run through three properties of cis that your book goes through on page 285 and 286. Being able to use these properties is a big motivation for writing complex numbers in polar form for us, being able to use the three of these and being able to use something else that we'll move on to later. So I'm going to do them slightly out of order from your book. I'm going to do property 1, property 3, property 2. I think property 1 and property 3 are the most useful and the most examinable. Um, Two, a little less so, a little trickier to remember as well. You do need to remember these as well. They're not in the log tables. They are derived from trig identities, but I wouldn't rely on being able to, derive them on the day. I would just learn these off. All right. So the first one is that the cis of A multiplied by the cis of B is the cis of A plus B. So to multiply two sis's together, just add the angles. All right. I'm just going to do the example which is in your book on page 285, which is to write the cis of 21 multiplied by the cis of 39 in the form a plus bi, so as a single complex number in rectangular form. Your book writes it out in full. It doesn't write cis 21 by cis 39. That's probably what it would look like in an exam. I'd say they're unlikely to use cis on an exam paper. They will write it out in full as cos 21 plus I sine 21 multiplied by cos 39 plus I sine 39. But anyway, we'll go on, we'll use this property. So we're going to multiply cis 21 by cis 39. So the cis of 21 multiplied by the cis of 39 is equal to the cis of 21 plus 39. So that is the cis of 60. Okay, so that's applying the property. Okay, so to multiply two sis's, just add their angles. To write it in rectangular form now, I will write cis out in full. So cis 60 is cos 60 plus I sine 60. So just evaluate this on the calculator then. So the cos of 60 is a half. So this is a half. The sine of 60 then is root 3 over 2. So plus root 3 over 2 I. Okay, no modulus to worry about there. To multiply out. So there it is. There is cis 21 multiplied by cis 39 multiplied together and then written in rectangular form. There's one I did earlier before I remember to press record on the iPad. Property 3 then is just the flip side of that one. So the cis of A divided by the cis of B is equal to cis A minus B. So to divide two sis's by each other, you subtract the angles. Okay, so the example I'm going to do here is different to the textbook. Okay, so if you were asked to write cis 75 divided by cis 30 in the form A plus BI. Okay, so cis divided by cis, I can just subtract the angles. So the cis of 75 divided by the cis of 30 is equal to the cis of 75 minus 30. That's equal to the cis of 45. To change that into rectangular form then, just write cis out in full. So it's cos 45 plus I sine 45. That's equal to cos 45 is root 2 over 2 plus the sine of 45 is also root 2 over 2 I. Okay, root 2 over 2 is also 1 over root 2, but writing it in that form is fine as well. All right, but there is cis 75 divided by cis 30 and written in rectangular form. Okay, again, exam question, unlikely to use cis, that abbreviation. It would be more likely to write it out in full, cos 75 plus I sine 75 over cos 30 plus I sine 30. All right. The property 2 then, the last one I will go through. There's a couple of parts to this one. Let's just remind yourself, cis is cos plus I sine. Okay, so if you have cos A minus I sine A, that's not cis. Okay, cis is plus. But cos A minus I sine A is equal to the cis of minus that angle. Okay, so this would be equal to cos of minus A plus I sine minus A, or cis minus A. The other part of this one is the cis of minus A is equal to 1 over the cis of A. So the cis of the negative angle is equal to 1 over the cis of that angle as a positive. So I'm doing the example from the book here again. So we're just going to, I think this one applies both parts of property 2. So write 1 over cos 45 minus I sine 45 in the form A plus B. I think I was writing that slightly differently to the way it's written in the book, but I'm doing the same thing. So I've got cos 45 minus I sine 45 on the bottom. Okay, so that's not the cis of 45, okay, because there's a minus there, not a plus. But the cos of an angle minus I sine that angle is the cis of minus the angle. Okay, so 1 over the cos of 45 minus I sine 45 is equal to 1 over, so just dealing with the bottom here, the cis of minus 45. Okay, now I'm going to use this step here. So if 1 over the cis of A is equal to the cis of minus A, well then 1 over the cis of minus 45 must be equal to the cis of minus 45 or plus 45. So 1 over the cis of minus 45 is equal to the cis of minus 45, which is just equal to the cis of 45. Okay, we're then just asked to write that in rectangular form. So to go from polar into rectangular form, you write your cis out in full. So that is the cos of 45 plus I sine 45. So the cos of 45 is, it's this one again, it's root 2 over 2 plus root 2 over 2. I sine 45 is root 2 over 2. I've seen it before. Again, root 2 over 2 can also be written as 1 over root 2, so they might write the solution like that. In the book they do, okay, but root 2 over 2 is the same thing as 1 over root 2. Calculator tends to write it like that. Elsewhere you see it, for example, in the special angle table in the log tables. It will write it as 1 over root 2 there as well. All right, but there's your 3 properties of cis. As I say, you do need to know those, but I would highlight 1 and 3 as being the more important ones. Okay, you do need to know 2 as well, but as I say, 1 and 3 the more important ones.